which I do realize is kind of strange. So we're going to skip chapter 9 and start off at page 7. So chapter 9 and 10 is about parametric equations. And what a parametric equation is, it allows you to represent two related motions with respect to time. And you also have to describe that movement along the curve. So you'll have two functions. X is a function of time and Y is also going to be a function of time. And we're essentially going to graph X and Y and eliminate the T parameter. Okay, so let's look at this first example here. I'm going to give you a second to draw in this table. Go ahead and draw in your table. Notice that we have three variables. We have time, we have X, and we have Y. And notice that the interval for time is -2 to +2. And that's why I picked these numbers. So you are specifically choosing your T values based on the interval that they gave you. And that interval is going to change. Okay, so I have my time, which says time is between -2 and 2, or T value, which is not really time because obviously time can be negative. So my T value is between -2 and 2. So -2 to 2 is T. And now I'm going to use these 5 numbers to find my X and Y. So what am I going to do? How do I do that? I substitute these 5 values into each parameter in place of T. So for this first one, it says X equals, let me go ahead and expand my page down a little bit. This first one says X equals 3T squared. So I'm going to figure out what is X if I put in all of the values. And you don't have to really write this down per se. So I'm just changing that T value. So go ahead and find your 5 numbers. So you're going to substitute in -2, -1, 0, +1, and +2. Okay, so your 5 values would be 12. Who got 12 for the first number? All right, what did you get for your next 4 numbers?
3.
Okay, good. So, how do you think we're going to find our next column? What are we going to do with those 5 numbers? Plug it into your Y parameter, which is easier because you're just multiplying these numbers by 2. Because for Y, it says you just take 2 times T. So you have 2 times -2, 2 times -1, 2 times 0, 2 times 1, and 2 times 2. So now to graph it, when you graph it, you're going to eliminate, because again, we're eliminating the T value, and we're only going to graph our X and Y. So we have these 5 ordered pairs that we need to graph. So notice that your grid does not have your X and Y axis. You need to determine where you put it. All right, and what I noticed is that, do I need to have, like for my X values, they're all positive. That was the first thing I noticed. So it really wouldn't make sense for me to put my Y-axis in the middle because I'm not going to use anything on the left side of Y because X is all positive. So what I'm going to do is I'm going to just move my Y-axis to the edge. And I also want to make sure that I'm not grading you on how you create your graph. You can create it whichever way you want to. I'm just telling you how I did it when I did the notes. So, okay. So I'm going to go ahead and I'm going to pull it off to the side. It's really hard for me to make straight lines on this iPad, so ignore the crookedness, sorry. And then, and I could even push it off to the edge really though. Let me move it over. Like I really could have made it on the actual edge. And then my x-axis, I'm going to try to put that in the middle. So something like that. And I noticed that for X, I need to go all the way up to 12. And for Y, I just need to go from -4 to 4. So what I did, again, I counted by 2s, but I probably could have even counted by 3s. So what I did, let me go ahead and make my, okay, so I made like, this was my 1, 2. So I made every other one count as 1 because I wanted my curve to be stretched out. But you can do it whichever way makes sense for you, because essentially you're just graphing your 5 points. So this is 1, 2. I'm not going to keep that, but this is what I'm trying to say. That's how I scale mine. So I'll give you a minute, take about 60 seconds or so to create your graph and scale it the way you want to scale it. And then we can graph our 5 points. So for my first point, I put it at 12, -4. So 12, -4. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I don't need this one. I'm going to take that one off. Okay. So 12, -4. And then my next point, so we have a point at 12, -4. What's our next ordered pair? 3, -2. And then 0, 0. And then 3, +2. And then 12, +4. So this is what your curve should look like. So I'll give you a minute. I gotta take attendance, I forgot to do that. Let me go ahead and trace that so that it shows up a little thicker. And then you put on there, the last thing is you have to show, because this is a curve. So when you look, can everyone look at the screen momentarily? We need to put arrows to show, is the motion going, I mean, are we traveling this direction or did we travel this direction? And the way we show the direction of motion is by adding a few arrows. So this represented t equals -2, so the arrows are actually, the motion is traveling this direction. So you just want to add a few to show the direction of the curve. So I'll give you a couple minutes to summarize that and graph that. And if you look in your homework that you picked up, this is the second page of that homework packet where you have to graph. So you'll have to create your table based on the interval of time that they gave you, or the interval of t, and then create your table, and then from there graph, and you're only graphing x and y. All right, does anyone need more time with this first question? Are we ready to start creating our table for the second question? All right, what is our interval for t for the second question? For example 2, what is our interval for t say? -3 to 3. So let's go ahead and start making your table. So now we're going to have 14 points. So go ahead, create your table, starting at -3 and going to +3. And just like on the last one, I'm going to give you a chance to find your values on your own. But to find your x values, you're going to take these 7 numbers. And this time you have to square it and then subtract 4. But for your y value, you're just dividing it by 2. So I'm going to freeze my screen and give you a chance to find your numbers on your own. And then we'll compare to see if you have the same values that I have. And again, you don't have to have a perfect graph. When I look at your test, I'm going to look at your table first. Obviously, to make sure you have the correct points. All right, who has the 14 numbers? Anyone still working on those 14 numbers? Okay. And then we can kind of figure out how you want to scale your axis, where you want to put your y-axis, where you want to put your x-axis, and how you want to scale it. put back up the calendar. I'm supposed to put up the whiteboards today, so that's why everything came in. But I at least need to have the bill scheduled up. So I can remember. Go ahead and put that back up. Okay. So these are the values that I came up with. All right, who agrees with my values? So now when we graph it, again, we're going to eliminate this parameter. And we're only graphing these to my coordinate plane. So when I scaled it, I noticed that my y, I really just needed to count by a half. So for my y-axis, for me, this is going to be negative. And again, you don't have to do it exactly like me, but I counted this is negative 0.5. This was negative 1. So I counted by, really by a fourth is what I counted by on my y-axis. And then for my x-axis, I counted by a half. So this was 1, 2, 3, 4, 5. So that's kind of what made sense in my brain. So you go ahead, take a moment and graph your 7 points. Okay, so my first point is at 5, negative 1.5. So that's going to be here. And then 0, negative 1. And then negative 3. Here, here. And then you just need to add a couple arrows to show the direction of motion. And that is your graph. That's it. And that's how you would graph a parametric equation. Mm-hmm.
So when you do your time, do you have to do every point? Like if I did negative 3, negative 1, 0, 1, 3, because you only need, what, 5 minimum? Or do you have to graph every single one?
We'd be good as long as it has the general shape. The one thing I should point out that I forgot to point out earlier is I want you to notice that I did not put, now this would be a point deduction on the test. Notice that I did not add arrows to the end like we would normally. And why do you think that is? It's a domain restriction. So if you were to add arrows, that would mean that t would go from negative infinity to infinity. So Karma just asked the question of, do you have to graph every point? I mean, essentially, I would be, I hope you would, but if I can tell the motion of the curve, your endpoints are correct. Where it makes this turn is correct. I mean, I'm not going to sit there and count every single point. But if you put arrows at the end, that would be a point deduction. And if you forget to add the arrows on to tell me the direction of the motion, then that would be a point deduction. So I really think that's just the main parts of this. Let's not make it complicated. All right, any questions about example 2? So we're only going to do 2 more examples and then we'll end there. So for our next one, I know this is a bad word because it's sine and cosine, but it's really not that difficult. You don't have to take out your unit circle or anything. So when you go around the unit circle, remember x is cosine and y is sine. It's basically asking you for the sine and cosine of 5 angles. So starting off with, let me give you a minute to create the table. I'm sorry, I forgot. You don't have a table. So take a minute, create the table, and then we'll go through it together. Well, you really shouldn't need the unit circle for this. There will be some unit circle questions on the final, obviously, because that was like 50% of the semester. I haven't thought about it that far. I think it's like one side is a unit circle and the other side is a cheat sheet. I know. Unfortunately, I just live my life where I only think about like the next day. I don't even know. I really can't even tell you like what's going to happen on Monday. I don't know. I have no idea. I forgot the final. I forgot what's on it. I don't remember it. I don't hold on to it. But when we finish this in the project, then I will kind of get back to that.
Is that a project?
There is a project which generally should, help the grades. So, all right, do we all have our table? Anybody need more time? Okay, so we're just going around the unit circle. I'm just going to make a quick sketch of the unit circle. We're not even doing the hard parts. We're not doing root 3 over 2 and root 2 over 2 and 1/2. I'm just asking you going around the unit circle. This point here is 1, 0. This is 0, 1. This would be -1, 0. And this is 0, -1. Those are your 5 points. X is cosine, Y is sine. So when we're starting here on the unit circle, here, the cosine is 1 and the sine is 0. So my first point is 1, 0. And then I go to 0, 1. And then it's -1, 0. I'm going to go through this one pretty fast because this is just going to be a circle. And then you end back where you started. So those are your 5 points. So again, this is just going to be a circle. So when you graph it, I'm going to center my X and Y axis. And I kind of created it, like I tried to make it so that it was kind of even. And when you plot your points going around, it's just a circle. So this one is a circle. And I kind of sketched it kind of quickly there. And this is the direction of motion. And that's that. And the last thing we'll do today, and again, I will record class tomorrow and Monday, and I will post it. Tomorrow, we're just going to finish out parametric equations. And during my prep, I'll kind of map it out and see, if I can afford to not teach on Monday and see, and I'll look at that. And I'll adjust the calendar accordingly, so. Because I remember how important prom is. I was in high school like 100 years ago, and I remember. All right, so let's get started here. So for our last thing that we're going to talk about today is how do you write a Cartesian rectangular equation. And there's 3 steps. So the first step is going to be to solve the x parameter for t. And we're going to kind of work through the steps as we do it. So the first step is I'm going to take my x parameter and I'm going to solve it for t. So in this equation, I have x equals t squared plus 4. How am I going to solve this for t? What would be my first step? Add the 4. And then how do I get rid of the square? Take the square root. Good, yep. Okay, so I'm left with plus minus the square root of x plus 4 equals t. And we have to add that plus minus because if we think about if you remember, the graph of a square root would look like this. This is what the graph of a square root, oh, that's kind of ugly, let me do better. That's what the graph of a square root looks like, but we want the entire curve, which means we also want to include that part, which is why we need to add that plus minus in front.
Would you not simplify so 2 root x is like the square root of 4, or is that not?
Oh, you mean like take the square root of x and the square root of 4?
Yeah.
No, because of the addition, you can't. If it was multiplied, we could do that. So now what I'm going to do is take this, step number 2 is substitute t in your y parameter. So I'm going to take this right here and I'm going to put it right here, essentially. So that's going to give me y equals, and now I'm going to put that yellow box that I have there, that plus or minus square root of x plus 4, right there. Now, the third step is to solve for y, but this is already solved for y. Sometimes your y parameter is not solved for y, but in this one, it's already solved for y, because when we look at our equation, do you see how it already says y equals? So that third is a moot point. I'm just putting it there, but in this example, that's already done. So this is my equation. Notice what I did was I created an equation where I eliminated t, just like we did when we graphed it. We eliminated t. The last step, which is going to kind of jog your memory, is you have to write the domain. So just to kind of give you a reminder of domain, there are 2 red lights. The first thing is you cannot divide by 0. So we can't have a 0 in our denominator. And square roots have to be greater than 0 because you cannot take the square root of a negative. So when I look at my 2 original equations, we don't have a red light. So these are good. But in this one, what red light do you see? What do we have here? A square root. And this has to be, this x plus 4, this has to be greater than 0. So for our domain, when we create our domain, what's underneath the square root has to be greater than or equal to 0 because you cannot take the square root of a negative. So when I solve that, what do I get? X has to be greater than or equal to what? -4. Does anybody remember how to write that in interval notation? I know this is going way, way back because we haven't had to do that in a long time. Who remembers how to write that in interval notation?
A bracket.
And that's it. Do we put a bracket on the infinity? No. And that would be your domain. All right. When I call you up, you can see your tests. Again, I do realize the sub-assignment had an issue. We're going to just